Hey guys, be right back. I got him upside down. Okay. There we go. Alright, this shoves through here. Mm-hmm. Huh. Okay. I don't know why this gear doesn't seem to be wanting to go all the way in. Okay. What the heck? think it needs to go in even more. Whew, got it. Alright. So this gear right here, this black one, has to be shoved all the way home until its teeth are all the way in this white thing. And this white thing, you can reach up and like drop it down, and you can reach on the bottom here and lift it up. And it causes this thing to come out when you lift it up. But yeah, I just shoved this gear back in. It has to go all the way in. You almost feel like you're forcing it, but it does pop in. You gotta keep wiggling it till it gets in. Alright, so that's big. That was really big. That was one of my big question marks, is getting that gear assembly all going. So now this becomes the next hardest part. The two black gears I was concerned with the most. Okay. Alright, this door has to be up. Okay. Boom. Alright. So I lifted this door up, and then I got this gear lined up back onto here. This little plastic shaft has to go into that. So that much I have down. And what else? Alright, so we take the two screws off, flip the door up, took that panel off. Okay, now the second screw. Now okay, it's toward the rear of the printer and down from where that shaft is. Toward the rear and down. Oh, okay, so it's that thing I pulled out. Okay, I'm getting that. Let me show you now where we're at. So it's this one here that I gotta put this onto, and it has a D shape to it. As does this, so that lines up where to put it. Boom! Pops right out as long as you got the D lined up. Okay, so now it should all be working, but we gotta screw it down next. There's all kinds of screws everywhere. I guess it might be these. Man, we're really off to the races now. Everything else is just simple stuff. Those two gears were all that I was really concerned with. Getting all the gearing systems of this weird door sorted out. Everything else is just panels that just bolt on or pop on. That's no big deal. This is the only mechanical stuff that I was concerned with. Okay, now this screw. Heck, I remember the next step. It was this. I think. Yeah, it was. And then this screw goes here. Memory's nice if you can remember anything. Okay, that screw doesn't fit. It's got to be a different screw. Don't tell me it's this giant screw here. Yeah, I think it's this gigantic screw. Whew! Get wrecked, kids, doubters, haters, get wrecked. The first gear I installed, it just had to lift the rack all the way to the top before sliding it in, which I did. The second gear was all keyed off of lifting that rack, and it was also a D-shaped attachment to the other end of the shaft of the original gear, which was already slid into the position. So everything was already quote-unquote timed or lined up. There's no problem. The first gear is here. The black one, the rack was slid all the way up till it was home. It's all lined up with the teeth. And the second gear is this one, and it has a D on it, and the doors are all the way open, and it slid right into the doors teeth, which are right here, and all that worked perfectly. So everything's good. I think it's all perfect. All the teeth of all the gears are lined up right. I don't really think there's timing involved anyways. I think that if you open this door, it automatically decouples some of the main gear trains from the normal gears just by sliding them outward. it's not really going to change the timing of like the print speed or something like that. It just is a safety mechanism so that whenever you open this door it will stop printing. Nothing can move anymore. It's like a clutch or something, or a transmission, I don't know. Maybe I'm not saying the right words. But I think it's fine. Everything looked fine. I mean, I couldn't improve on what I just did. Alright, so that's done. Let's see. Alright, so it was this panel we took off. Before that, we took that gear off really quickly. I didn't really explain that part. And then this gear we took off, which I just put back on. And then the door we bolted in on one side and on the other. And then we bolted this front left panel on. And then, oh, we can close it now. Okay. Uh-oh. Maybe... what? Ah! Okay. Let me just show you guys what I had wrong. So you saw it. I didn't see it. Okay, so this had to be rotated so that this side of the D was facing the front of the printer right here. And this little notch right here had to line up with the bottom notch on this thing. So I had to lower this thing down on this rack after lining it up. This is all lowered down right now to the lowest position in order to make this D front face be right here, and so that this whole thing could have this little notch line up with the bottom of here. Now I think this will, I'm like pretty sure this will work now. Nope, it's still clicking. What the hell? Okay, it stopped clicking. Maybe... I don't know what changed here. Like, I thought I had it, and then I was wrong for sure. And then the second time I thought I corrected it, and I thought I was for sure right, and then it was clicking anyways. No, everything feels okay now. It's weird, it just had some hiccups the first time. I think we're okay. That was scary because... Oh my gosh, you gotta be kidding me. Dang. This whole time I wasn't even showing what I was doing. Let me just show you guys what I was doing again. Good grief. Alright, so this is how this all looks. The first time down it was making clicking noises, so you can see a bunch of stuff down here starts moving when this door moves. Kind of weird. And you can see everything seems pretty smooth now. So it took that adjustment, thanks to TXT for bringing that up. Everything looks really good now. It sounds good, looks good. So I think we got it. But yeah, it wasn't lined up with that key on the second gear. It was lined up with the keyed shaft, and I did lift the rack like it told me to, but then I don't know, it seemed like the rack had to be down after all or something. I don't know. But no more clicking, so that's good. We're mucking about with this panel, and then we took off this gear, which we just put back on. Then we put on the 2 screws for the top cover, then the corner of the top cover. Check, check. Okay. And then we close it, which we did, and we tested all of that. Lock it down, we did that already. I believe the next thing is the back cover, yeah. Alright, so the back cover should just snap on. Let me go around to there, have a look at it. Why is it like that? That's ridiculous. I might as well not even show you the screen I'm looking at here. So, I need to bring my camera with me, I guess. Ugh, 'cause I'm not turning this thing. Yeah, this looks right. Everything's just a feel, I guess. What is this supposed to snap into? Nah, something's wrong. Yeah, that's what I thought. That's right. Got him! Another one bites the dust. Another panel back on. Too easy. Except kind of not easy, but I mean, we're progressing for sure. This thing's coming back together, man. Oh, the left rear. Alright, so the next thing, we just did the back cover. I'm in reverse right now. We did that. Now, the next thing I messed with was popping off this internal left rear panel thing, which is right here. You pry it free from the front and then you yank it off, twisting it, pulling it. So let me try to find that. Oh, I've got it right here. Nice. These panels were all over my room, and so I moved them throughout the basement to other rooms of the house. And I pulled in some of them randomly, and it looks like I pulled just the right one so far. Okay. I keep forgetting to switch back the scene to showing what I'm doing instead of showing the monitor. Alright, so we've got this panel. I've been trying to figure out how it goes. It goes like this into this corner. Oh yeah. Got him! Another one bites the dust. Man! Ooh, this is gonna be a big one. Oh yeah. The left cover goes back on next. And I got it right here. Need more room. Of course, stupid bull stuff has to always fall. Ugh. Okay. Yes! Yes! Okay, the left cover's on. Yeah, wouldn't you guys love to see me give up on this printer and let Mailbox heckle me for the rest of my life? Not a chance. Mailbox would never let me forget. I will never give up on or fail on any project I ever take on, period. There's professional pride at stake. There's reputation at stake. There's my ability to believe in myself that I can do anything I put my mind to. And that starts with always succeeding no matter what I do. You start giving up on projects when they get hard, and where does it end? Might as well give up on everything, not even get out of bed. You're either in it to win it, or you're in it to quit. Looks like there was one screw in the bottom here. No, it said not to use an electric screwdriver. You can easily break these things. It's all screws going into brittle plastic. Oh, this door goes onto this panel, and this panel's not on, so we could leave this door off. As a matter of fact, I think we're good. Yeah, we're good. I think it's put away enough, actually. As far as panels, we only have 4 more panels that could even go on. So this thing could be plugged in and tested right now, I think. Should I do it? Oh man, that's scary. I'm scared to test it. I mean, I guess it's all put back together for the most part. Oh, you know what? Definitely needs the imaging drum. I'm gonna test it. That's the one thing that's not in. Well, I don't mind turning it on. If that's what we have to do, that's what we have to do. Who knows? What if it works right now? Because I said that in retrospect, you know, days of thinking about it, working on it, that there was a chance I had something jamming the pickup roller gears, and turning it manually after I opened it all up might have fixed that right off the bat. In which case, we could already be done. It might all be working now. Alright. Here goes nothing. This could... Well, it's going to tell us a lot, one way or another. I don't know what's going to happen. Should we take predictions? Some people say it's going to blow up, I see. Yeah! Okay. Really scared, man. What if I just see smoke coming off this thing? I'd know where this fire extinguisher is. Uh-oh, it's starting up. Holy crap. Sounds pretty good. Whoa. You can actually see the gears turning. What the heck? What? No way, dude. That's so cool. Man, they turned fast. I was not expecting to see that. That's like scary fast. Oh! It said ready. Alright, well, what do we even want to do, guys? I'm scared. I'm too young to die. I mean, that's great. The whole preparation sequence required the whole thing to work. So now the only question is, will the pickup roller work? I guess we just tell it to run a test print. If that pickup roller turns, we fixed it. If it doesn't turn, we can start troubleshooting why that's not turning. So I'm going to go menu. I think system setup. No. Cancel. Menu. Copy setup system. Reports. Demo page. Alright, so this thing taped down tells it we have paper. So it thinks we have paper. It's going to try. Alright, so this is all prep work. If that turns, we learned something here. Paper jam. Clear the jam and press enter. I heard the clicking and everything. I didn't see this thing turn, did you? Let's watch it again. I think the solenoid didn't get a signal. If it gets a signal, that thing is going to pull out. That little lever right there will pull out. And I saw this thing. Look, it's turning right now. That's what you want to see turn. And it turned, meaning this magnetic clutch is working. But that thing didn't pull out. It did pull out, actually. I saw it pull out twice. That was that tick, 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 tick. It pulled out. So what the heck is going on? That solenoid's working. Jam and tray 1. Solenoid lifted up twice. What is going on? What is going on, man? Okay, what? If the solenoid turns and everything seems like it's working. No, I would definitely put the side cover on. This solenoid frees up the latch, which goes to the pickup roller. The pickup roller is driven by a shaft that goes through the center of this magnetic clutch. This magnetic clutch is supposed to turn the shaft. Maybe the magnetic clutch is not strong enough to turn the shaft? Is it not biting down hard enough? That's a possibility, I guess. Did you try to turn the shaft? Yeah, by hand with this magnetic clutch off. I turned the shaft and I saw this thing turn. And I turned it by hand, no problem. I don't even know where to begin now. I'm lost. We're back to square one, folks. I don't know, I guess I can keep watching and do all that stuff. If it's pulling that, what's stopping this from turning? I'm manually pulling out the solenoid right now, which shouldn't hurt anything. What? What the heck just happened there? Oh. I felt it lift with me, but we've already established that has nothing to do with it, right? Because nothing turned. Despite me lifting, nothing changed. It helped me lift though. But that's the part where we would have heard the click, 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 click. That's normally the clicking attempts of the solenoid. So that's the part. That's why it was just quiet. All the sounds were different because I was already pulling it out. That's why I didn't hear the clicking. And then it just said the normal jam. So I just ruled out the solenoid because I did the solenoid shot and pulled it away and the thing never spun anyways. So that tells me it's got to be this magnetic clutch. The stuff missing from the front is just the paper one feed tray that you set the papers in. And then also the cover that normally covers up this thing to keep dust off. That's just two little parts that snap on. It's not a big deal. It's not required at all for any of this operation to work. It doesn't even know those aren't attached. There are no sensors that sense any of that. The only sensor related to that stuff is this one taped down right here, which senses that the paper is all the way in. And I just taped it down so that the printer doesn't know there's no paper. So that has nothing to do with it. Our problem is this thing never turns. That's the pickup roller. That's what picks up the top page. Now, the solenoid has to free the pickup roller to turn for it to turn. I just manually pulled it out and it still never turned. It never even tried to turn, not even a budge. So that tells me stuff. Bad stuff. I still have no clue what's going on. I have no clue what's going on whatsoever. Well, we're well exposed though. No, there is no failure. I've still got plenty of plan Bs in the works, which I've written down and everything. I anticipated something like this happening way early on. But I want to try to narrow down what's wrong for my own education and possibly for an easy repair, just to open up options. Worst comes to worst, we can always just manually turn this thing. And by manually, I mean using our own control systems. I can create my own motor setup, my own gearing setup, my own motor power delivery mechanism, my own microcontroller, my own timing setup, everything. to make this thing just work when it's supposed to work. And that'd be a whole Arduino solution, basically building my own little miniature robot that does the paper pickup. And that's not failing. That's perfectly within the rules to add your own workarounds to faulty, failing, broken parts. But if I could try to find the part that's failing, that would be ideal to me. The magnetic clutch might have failed, huh? So it might be producing magnetism, but not enough to bite hard enough to actually turn things. Correct? It has too much slippage, maybe? Let me try to manually turn this roller. Is my head right in the way? Okay, so this would pull out, and then this would do one full turn. Pulls out. Everything seems free and easy and stuff. The magnetic clutch turns clockwise when I do this. Alright. I want to see if it turns clockwise when I do this. It's turning clockwise now. But why isn't that turning? Is the cup... I don't get it. Why wouldn't this thing want to turn when that's turning clockwise? If they're coupled, they're coupled. Unless if they're not... Is there another clutch? That's so weird. I'm confused. There's got to be another clutch involved. There's got to be another clutch involved. Okay, this clutch is decoupled from this thing. Yes, it turns when I turn this thing, but it also turns at times when this thing's not turning. So, by default, it is coupled to it, but something internally decouples it at other times. Because I see this green thing turn on this magnetic clutch, which is the center shaft, the same as it's turning now when I turn this pickup roller, but I can also watch this green thing turn clockwise and this pickup roller not get any juice at all. It's not turning at all. So there is a second coupling mechanism that comes into play besides these two things that is failing. There's something else too, and I don't even see it. It's deeper in. It's something even deeper. There's more going on. There's more, there's more, there's more. And I don't even know what it is. The pickup roller shaft is definitely not the same shaft that goes through this magnetic clutch. It's a magnetic clutch, it's not a motor, and no, it is not the shaft that goes through it. But if I turn the shaft that goes through it, it does cause the pickup roller to move. But that shaft can move also and the pickup roller not move, meaning it also can be decoupled from yet another magnetic clutch. There has to be a second magnetic clutch. There are two magnetic clutches. In fact, if I search the manual on the printer, I bet you clutch will come up more than once. And that's kind of my giveaway. I think it's the other clutch that's failing. I really do. Aha! This outer clutch is the one I've been playing with. Number 2, and that is the registration clutch. The roller engaging clutch is what is failing me, and that's behind the gear assembly. No wonder I couldn't see it. It is buried away here. That's it. That's the clutch that is directly coupled to my pickup roller, and that clutch is what we need to test and access. That clutch is what's failing right there. No wonder I just was thrown off because there's multiple clutches involved. Both of these clutches are coupled through a gearing system, but this clutch number 1, the roller engaging clutch, is what is not working. That's 100% guaranteed because I've ruled out the solenoid. The solenoid's 100% working. And it's that clutch. That clutch is not translating anything. Yes, we figured it out. Now, it is located centrally in the gear assembly. How centrally? This should be like right back behind here. I think I'm looking at it. It's funny that if I help it, it does turn. Watch. Actually, it turns at the beginning too. See that? It turned. If I pull out the solenoid, I get it to turn just by giving it a little nudge. Especially during the setup phase when the registration clutch is activated. I wonder if I just kept doing that, briskly rubbing on this, if the solenoid would pick up at the right time too. And it would just turn at the right moment. It's like it just needs a little help. I'm just going to keep tickling it, so at the right moment it will get just the help it needs. Yeah! I got it to turn twice. All I gotta do is just nudge, nudge. Wow! So it would work if it's just being nudged like this. Repeatedly. Just brought, nudge, 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 nudge. These are not even coupled to it. So this does nothing. This does nothing. It's just this. Even just tapping here I bet would work then, because this is coupled as well. Let me try. If at the right moment it gets just a tap, then it turns. And the solenoid works. Everything works. It just needs a tap. That could indicate a weakened magnetic clutch for the pickup roller system. It's not biting enough, so this just gets it a little oomph just to get it moving. It just might not be, because a clutch is like a grip, it's like a friction grip, and it's not gripping enough to make the turn start. Alright, watch. Boom! And that would have printed right there. It worked. So if I create an Arduino based tapper that just taps like this, it would work. But I'm curious, was my finger going to get in the way if I left it there somehow wrong? If I just have something do what my finger is doing, it will work. That's how we check car AC. You tap it with a screwdriver handle and it will engage because the magnetic clutch is too weak to pull the clutch plate in. Exactly. Is that an indication that the clutch plate has worn out? Or what? I'm excited! This is totally doable, guys. I mean, or we could try to fix the clutch, but to do that, I've got to... I mean, that's a huge amount of disassembly work. I don't really want to take apart this gear assembly. Oh, it's deep buried in here. That. Press space. Paste it. Press space. Part number. Press colon. Press space. Paste it. Is too weak to pull the clutch. Press return. Plate in and engage. And if we tap on the pickup roller gently, repeatedly, comma, we give the clutch plate, press return, enough assistance to get it to turn the pickup roller at the appropriate time. Exclamation mark. Stop listening. Wait. Press space. Note that the, press return, clutch we were testing before which was on the outside of the gear assembly was the registration, press return, clutch, and was not the clutch at fault in our situation, press semicolon. The roller engaging clutch is located, press return, near the center of the gear assembly and is located deep inside where you have to remove the gear assembly to get at it. Gear, press return. At it. Stop listening. So a band-aid fix would be to create a system that's going to tap, 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 tap to try to get it to turn. Another solution would be to actually just create a turner, not a tapper, but a full turner. Not something that's going to assist the turn, but something that's going to actually turn it. And that'd be a permanent solution. All that would have to do is read into when the solenoid kicks off, and then it'd turn then. Or we could try to take it apart and get at that clutch and try to fix the clutch. That's the thorough, all-in way to fix it. Wait, you're telling me the clutch coil, so the inductor, is worn out? How does that get worn out? Why would replacing that work? It's just a copper coil, right? I think we should go with the Band-Aid fix, maybe. Like the easiest fix, right? That's the smartest fix. The easiest. Isn't it? Well, it gets turned on like 5 times a day. It has to engage. And I'm thinking, you know, it does engage. It just needs a little nudge of help. That might last for years. Maybe 3 years if I just give it something that gives it a little nudge. And then after that, we could, once even a nudge doesn't work, then we can create a complete turning system that just turns it from the outside with Arduino. So how would a nudger work? I feel like, okay, I feel like a nudger system would work for a long time. Possibly a couple years, maybe 3 years, maybe 4 years. And who knows, I mean, that might be the first thing to fail. Other stuff might fail on this thing, so do we really want to be taking it apart anymore? I don't think so. I want to cut my losses. This thing is limping along anyways. Or is that the wrong mentality? Like, we're setting a precedent here. I'm pretty new to repairs. Is it wrong to create a repair that's like a Band-Aid fix? Is that bad? Should you always, quote-unquote, do the fix right in a permanent style, quote-unquote permanent, nothing's really permanent, but actually fix that part, get inside all the way in until we find it deep inside here? I mean, when you can just fix it from the outside without taking apart anything else. I can bolt this thing back on, slap on 4 or 5 panels, and we have a working printer and a nudging system from the external part. We can take detailed notes on what we fix and why we fix it that way and how it's going to fail eventually when it does fail and how we can fix that. 2 different methods for that. And address that later if it's ever needed. Who knows? Maybe it would never. Maybe it would never be needed. Maybe this Band-Aid will work forever. I mean, sometimes Band-Aids do. And it's that chance of it working forever that is attractive. Because you really never know. My house might burn down in a couple of years, and then I'll be glad I did the Band-Aid rather than have to take this whole thing apart and possibly really break something. There's a lot of moving parts. You got to take off this in order to take off that gear, in order to take off this gear, in order to free up these gears. And then you've got to take off 8 screws and an E-ring and the registration clutch and unplug at least 3 things, including the registration clutch, the solenoid cable. You have to unwire loom several things. There are hidden screws I couldn't even find. There's a spring activated ground system behind the gear assembly that can get messed up. I mean, there's a lot at stake removing the whole gear assembly. There's a lot at stake. It's just not practical, in my opinion, to ever do it, honestly. There's just way too many parts involved. It's a mess. For me to be back up and running with the successful repair in Mailbox's face, that sounds like a win to me. And I wouldn't mind creating a system later on that simply turns this pickup roller for me from the external. I mean, unless if that's the solution now. Maybe that is the solution now. Why would we create a bumper that's just going to bump it until it activates? Why not create something that just turns it with enough strength to actually turn it on cue? That seems pretty reasonable. That seems pretty darn reasonable. Ah! if we can find out where the 24-volt signal goes to the actual clutch, that would tell us a lot, because that could be our cue. Hey, this is when it should start turning, and immediately when that signal is sent out, and we can assume that signal is working, we're assuming the clutch electromagnetic field is not strong enough. So if that signal is working, that would give us an exact cue for when our turner should start turning, when normally the clutch would be doing the work. Now the clutch is still going to be working, so it's going to assist that, but our turner should be strong enough to turn it independently as well. And then the solenoid brakes will be released, and then it will start turning when the appropriate time is dead on. What would be the equivalent of a clutch? You said, how much pressure does it take to make it go? Oh, barely anything. I'm putting on, I mean, I don't know, 1/16 of a pound of pressure? Barely anything. Motor that turns something flat and flexible. I was thinking about like connecting a little pulley to a rubber band and putting it under tension and then having that turn, and that would put on a decent amount of pressure, enough to probably turn this thing. Like a pressure-based system, but it would need to be able to slip. That's why actual rubber gears I'd be concerned with, because that would strip the gears over time. It needs to be able to slip in order to not turn when it's trying to turn without breaking something. Unless because the motor could just struggle, and I could set it up to pulse width modulate, just keep trying, bump, 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 bump. As soon as it's free, it'll start spinning freely. So it will just put pressure on it, trying to turn it, but nothing too crazy. So then I could actually have it be completely coupled to the shaft of the pickup roller. So it could just be my normal pulley system, just a motorized, just a little motor with an output shaft with a little pulley on it with the string wrapped around that and glued on. And as the motor turns, it's like a fishing reel, and it turns the string, and then it's also wound around the pulley shaft. The motor will just keep trying to turn and meeting resistance and failing to turn, and it won't turn real hard. It will sense its voltage going up at a certain point. It'll just give little test turns until it sees it's freed up because the brakes came off from the solenoid, and then it's going to turn full bore when it sees things are free. So it'll just keep doing little gentle test turns. It could read in when the solenoid actually frees too, though. I mean, if its timing is quick enough, as soon as that solenoid gets a signal, it could immediately start to turn. That'd probably be fine. Yeah, that'd be fine. The solenoid lifts up twice, and it smacks back down. Probably just, the second one's just a redundancy. When it first lifts up, my thing's going to start to turn immediately. So it could just cue off the solenoid. Heck, we could run the wires right off the front here. The solenoid's right here, and it's got two little yellow wires right here. All we'd have to do is come off of those and create a little voltage divider right over here somewhere, and then send that to an Arduino, which could be right around here somewhere. Unless if we want to put all that stuff underneath. Yeah, we should probably route it like through here and mount the little Arduino down here. We don't want it to interfere with anything under here, but I think this was empty. We'll have to put everything on and see where we have space. But we could put our motor, I don't know, like right here or something. Just a tiny little baby motor with a little pulley, and wrap around right here. And it will just turn. And it will cue off of this when to go. Heck, we could use, since we're only getting one input and then one output, We could use one of those Arduino A-Tinies or whatever. The tiniest one. I bought some of those. They're only 8 pins. We could use the tiniest little Arduino and program it just to turn on as soon as this turns on. I could even have it have a little display indicator light, a LED that comes on showing it's trying to turn. And it'll just turn at the right moment. As soon as the solenoid signal triggers, it'll turn, and it'll be helping the existing systems, which won't be, they'll all be stock, but it's just an assister. But even if that second clutch completely fails, which I don't think it'd ever completely fail, I mean, it's just a weak magnetism, right? Then it's going to do more and more work as that clutch fails more and more. But the point is that it will be helping out, and it will help out on cue. It won't be like just putting unnecessary pressure and strain on the system for no reason at the inappropriate times. It's only going to do it when the solenoid triggers, meaning it's go time. I'm going to do it this way, guys. I decided. I'm not going to take it apart anymore. I think that's easiest, best, and it also is an electronics project demonstrating skills of a roboticist, which is what I have to bring to the table. I'll be saving myself work taking apart all this gearing stuff by just creating an assist system separately. I think that's the right move, and it's going to be a great Arduino project, which I will enjoy. I want to do more Arduino stuff. Yes, I'm still fixing the printer, and I've got it figured out. I have my final solution figured out, and I know exactly what's wrong with the printer. And that was what I was holding off on, not making any serious decision until I have 100% confidence that I have for sure figured out what's wrong. There is a clutch called the pickup roller clutch. And it's a magnetic clutch that engages and causes the pickup roller to turn. And that magnetic clutch is too weak right now to turn the pickup roller. And if I just nudge the pickup roller a little bit, just rubbing it gently, it does have enough strength to turn it. It just needs that little extra oomph. It's not quite strong enough. And so my fix is I'm going to build a motorized system to turn this thing on cue so that it's not only assisting, but it can actually replace the functionality of that weakening clutch, which is just going to weaken more and more over time, we suspect. And it will be cued off the solenoid, which is the brakes, which releases the brakes off of the pickup roller system. So I'm going to tap into this with a voltage divider circuit, and that's going to cue our Arduino to kick on the motor, which will then begin turning this thing. So we got it, boys. 100%, the plan is in place. This is going down for real. Could it be a greasing issue? Maybe. It wouldn't be WD-40, but we'd put some kind of gear grease. There's gear grease on all these gears. And there are some gears that look a little bit dry in here, to be honest. But well, shoot. I mean, should I try greasing it? That's not a bad idea, I guess. Nah, I wouldn't know which gear to grease. Nah, I'm going with my plan A. I'm not going to bother with greasing. The grease that's on here looks like it's lasts forever anyways. So we're good, man. We got it figured out. I know exactly what I'm going to do. And it's very exciting stuff. It's thrilling. Oh, what a wonderful opportunity to showcase my skills in electronics, my knowledge in electronics. Alright, so now I got to do all my documentation and planning, step by step, how to pull all of this stuff off. Detailed, exhaustive, step-by-step guide. I'm going to do that right now. Okay. 5-volt supply on laser printer diagnostic manual, which will feed our Arduino. Press return. Splice off wire from 5-volt supply on laser printer main brains DC controller PCB. Press return. Press space. Press space. And run it along the bottom right side and out to leave a bunch of slack for now. Press return. And pickup roller cover to see where we want. Press return. Press space. Press space. To mount our microcontroller, Arduino, and our motor. Press return. Press delete. Paste it. Press return. The laser and scanner PCB with its wiring harnesses returned to stock. Press return. Press space. Press space. Formation again. Press return. Run a splice off of 24-volt feed line running to our solenoid. For both yellow wires. Press return. Press space. Press space. And leave it long and slack for now. Press return. Press semicolon. Use DuPont male and female crimp connectors. Press return. Press space. Press space. And double crimp our splice line with the male or female crimp connector so that, press return, press space, press space. We are not using any soldering and have a firm mechanical connection. Press return. Do a calculation for the voltage divider circuit off the 24-volt solenoid feed lines. Press return. Press space. Press space. To determine what resistors are needed to run a safe 5 volt or less low amp. Press P. Signal. Press return. Press space. Press space. To our Arduino, which need only be high or low, to indicate when the 24-volt line has turned on. Press return. Press space. Press space. Press return. Create voltage divider circuit board using my DIP to SMT boards as a basis for press return. Connecting up the wires and soldering SMT style resistors to keep things very small. And mount this board somewhere convenient and out of the way. Run the lines 5 volt. Press V. That are to power the Arduino through the side of the printer and entering into the chamber the Arduino will be stored in. To sense when 5 volts is applied to its digital pin, indicating a high signal, press return. And have it output 3 volts to a micro DC motor for 1 second, and then press return. Shut off. Press semicolon. Then, comma, test this out on a breadboard using jumper pins and all. Smallest one we have. This tiny already programmed Arduino in a convenient place that is not in the way of anything. Press return. Onto our printer. Using spandex tape to do so. Attach the voltage divided 24 volt signal to the digital pin we programmed to receive this signal. This. And attach its ground to the Arduino's ground. Attach the 5-volt line and ground to the Arduino's 5-volt and ground to power the Arduino. Attach a digital output pin that we programmed for the motor to a motor mini. And attach that motor to ground pin on the Arduino as well. Between the micro motor's power and ground lines with an appropriate resistor, that will indicate when the motor is trying to be run. The motor and attach 2 circular plates onto its output shaft. That will guide the string, upholstery thread, that this motor will be using to turn the pickup roller shaft. Use silicone caulk to attach the plates. After first using hot glue to hold them down. In position. pre-wrap upholstery thread around the shaft of the motor a few turns. By first brushing on some contact cement on the motor shaft and on the upholstery thread and letting that tack up, and then carefully touching the tip of the thread onto the shaft and beginning to wind it. Then once that is all fully dry, wind dry thread several turns. A couple dozen turns. Rubber belt. That is to have rubber band-like thickness, so multiple layers of nitrile tape. With sticky sides facing in at each other, so neither side is sticky. But make the inner side grippy by applying rug anti-slip paint onto it. That it will use to turn the pickup roller shaft. Wrap its output shaft with nitrile glove tape until it is at least 6 millimeters in diameter, which will make it have a larger surface area with which to grip a taut nitrile rubber belt, which it will be using to turn the pickup roller shaft. The motor output shaft, comma, now mount the motor parallel with the pickup roller shaft using spandex tape to tape it into place tightly onto the printer. And plug the motor back in to the Arduino. Now create the belt with thin layers of nitrile glove tape facing sticky side out and pulled substantially taut substantial whose non-sticky side must first be coated with anti-slip rug paint to make it very gripping. Press semicolon. Next, paint the motor output shaft with anti-stick slip rug paint to make it grippy. Coated. Wrap the tape around the motor output shaft and the pickup roller shaft. Press return. and then wrap several layers thick nitrile tape facing sticky side down. Press return, which will sandwich all the sticky sides, leaving no more sticky sides exposed. Press return. And build this up in layers until it is the thickness of a rubber band. Now coat the pickup roller shaft with anti-slip rug paint where its belt, our belt, will be contacting it. Press return. Also, comma, experiment visually with getting the motor pickup roller to turn on the laser printer and match the rotational speed with pulse width modulation of the DC motor. Press return, so that we can get a speed match approximately. And ensure the motor turns counterclockwise. Press return. As we will mount it facing to our right. .1 UF ceramic capacitor and one N4004 backflow protection diode. Press return. As the protection circuitry on the DC motor to prevent it from frying our Arduino. Frying. Is it safe to connect a small DC motor to an Arduino directly? Switch on a small MOSFET. Power on a it. Locate 24-volt supply on laser printer diagnostic manual, which will feed our DC motor. Miniature. Splice off wire from 24-volt supply on laser printer main brains DC controller PCB. And run it along bottom right side and leave a bunch of slack for now. We will buck this down to 5 volts, but are using this instead of the 5-volt line. Volt. Just in case the motor would pull too many amps from the 5-volt line. Which was only designed to power the logic and not motors of the printer. Close parentheses. and mini motor. Miniature. And attach that MOSFET to a buck converter set to convert the 24 volts down to 5 volts for our mini motor. The 24 volt power supply rail for our mini motor to a buck converter that is set to convert that down to 3.3 volts. MOSFET. Press return. And ground. And its protection circuitry. Backflow. Time back, I say... Stop listening. I say in here that I'm using a buck converter to reduce the 24 volts down to 3.3 volts for the motor. I'm not going to feed a 3.3 volt motor 24 volts. Wow, you guys really think I'm that bad at electronics? Wait until you see how much better I am at electronics than you ever imagined. Wake up. Test and perfect my repair job. That's not true. I'm going to be using all surface mount components. Stop listening. So this is going to be using a miniature motor. Stop listening. The size of the last metacarpal of my pinky finger. And the rubber belt is going to be about that big total. And the Arduino is going to be one that's like this big. And all the other supporting circuitry will be on little circuit boards like that big and that thin. So this is going to be like the whole solution will be smaller than my thumb in volume, and it will be spread out. This is going to be tiny, tiny, because that will exercise my skills at keeping electronics small, which I think is very important, especially when I get into micro scale stuff, which is going to be required for all of my robots. Even the bigger robots require some aspects of it to be micro scale because they're very complex. And so you can't just make everything huge. You have to learn to make things really small. And I've been studying all that stuff. I'm putting a lot of electronics knowledge to the test with this project. This is going to be, I mean, besides my power supply project, this is going to be one of the biggest, baddest projects I've taken on ever, as far as electronics goes.